Welcome to the exam preparation for DP-100, Designing and Implementing a Data Science Solution on Azure. My name is Aravind Sridharan, and I'm a Microsoft Technical Trainer. In this video series, we'll guide you through the essential strategies for taking the DP-100 exam. Our focus is on exam strategy and preparation, not teaching concepts. We'll cover the objectives, best practices, tips and tricks, and key points of the exam. This video will also include a lot of visual information for reference. Remember, you can always pause the video at any time to review the content. This exam is designed to validate the knowledge of data scientists working with Azure, to run exploratory experiments and train predictive models, and also managing, optimizing, and deploying machine learning models into production. You're also expected to know how to optimize large language models for generative AI apps. Your path to becoming an Azure Data Scientist Associate involves several steps. This video series is your comprehensive guide to exam preparation, covering essential topics and providing valuable study resources. Be sure to also make use of our labs, study guides, and practice tests, and focus on the skills highlighted during the exam prep course to ensure you are thoroughly prepared. Once you feel confident in undertaking the exam, it's time to take the exam. Now let's get started. The exam prep video series will help you with 3 key things. Identify what will be covered on the exam, gain insights on preparing for the exam, determine which concepts to prioritize/revisit for further study. Keep in mind that this series is not a replacement for official Microsoft training or your hands-on experience. While it will guide you through on what to do and what to expect for the exam, it won't teach you the topics in detail. Use it to spot any knowledge gaps and focus your time and resources accordingly. In this series, each episode will cover one of the 4 groups in the objective domain. For DP-100, these groups are: design and prepare a machine learning solution, explore data and run experiments, train and deploy models, and optimize large language models for AI applications. Each group has a specific weight, indicating the percentage of questions that will come from each area. Currently, Episode 2 is the most heavily weighted section. You may consider focusing more of your study time there. However, to pass the exam, you need to be familiar with skills in all groups. The exam will now cover Azure AI Foundry, which will be covered in Episode 4, while Episode 3 is mostly focused on Azure Machine Learning. There will be less of a focus on ML Ops as well. Let's dive into the content of Episode 1, which focuses on designing and preparing the data. In this episode, we'll cover how to design a machine learning solution, create and manage resources in an Azure Machine Learning Workspace, create and manage assets in an Azure Machine Learning Workspace. Here's a list of all the different skills you may be tested on. We'll cover how to design a machine learning solution, create and manage resources in Azure Machine Learning Workspaces, and creating and managing assets in Azure Machine Learning Workspaces. In the latest version of the exam, we have included registries, which is something you should be aware of. These are sometimes referred to as may include, meaning they may or may not be on your exam. This list isn't exhaustive, and while we won't be covering every skill in this video, be sure to be able to perform these skills before taking the exam. It's crucial to understand the 3 types of data sets: structured, semi-structured, and unstructured data. Structured data is highly organized and easily searchable, like data in a relational database. Semi-structured data has some organizational properties, but not as rigid as structured data. Unstructured data lacks a specific format or organization. It is vital to be able to answer questions on the exam regarding data sets. Understand how to find the right compute for your workflow, CPU or GPU. For smaller tabular datasets, CPU will be sufficient and cheaper to use. Whenever working with unstructured data like images or text, GPUs will be more powerful and effective. Understand the difference between general purpose or memory optimized compute options. General purpose is a balanced CPU to memory ratio, which is ideal for testing and development with smaller datasets. Memory optimized is higher memory to CPU ratio, best for in-memory analytics with larger datasets for when working in notebooks. Spark clusters in Azure use the same sizing as virtual machines, but distribute the workloads across multiple nodes. This parallel processing reduces overall execution time. And also know how to monitor your compute utilization. To monitor training time and compute usage to determine if you need to scale up or down. If training is slow, consider using GPUs instead of CPUs or distributing the training with Spark Compute, which may require modifying your scripts. Automated ML. Make sure you know it simplifies model training with minimal coding. Notebooks allow for detailed control over model training. It's ideal for custom models. Notebooks can eventually be converted to be run as command jobs, which is beneficial in terms of a scalability and from a maintenance perspective. Sweep jobs, be aware of its ability to optimize hyperparameters efficiently. An additional point to be aware of is that your go-to SDK for the use of these scripts in command and sweep jobs should be based on the version 2 SDK for Azure Machine Learning. Understand the importance of creating an Azure Machine Learning workspace. A workspace defines the boundary for a set of related machine learning assets, which can be grouped based on projects, deployment environments like test and production, teams, or other organizing principles. The main components of a workspace are compute targets, data for experimentation and model training, notebooks, experiments which include run history with logged metrics and outputs, pipelines that define orchestrated multi-step processes, and models. Be aware of the different ways to create an Azure Machine Learning workspace, such as through the portal, Azure CLI, or programmatically using SDKs. Remember that assets and resources are created as part of a training run. The resources created are when initializing the Azure ML resource in Azure R, a storage account, an application insights instance used for monitoring predictive services, an Azure Key Vault instance, and a container registry. With Azure Machine Learning, you can connect to various data storage services using data stores. Make sure you know the requirements for creating each type of data store. For Azure Blob Data Store, you need an identity-based access and account key or SAS tokens. Azure Files Data Store requires an account key or SAS tokens. Azure Data Lake Gen 2 or Gen 1 data stores need identity-based principal access or service principal. Be aware of these requirements to ensure smooth integration and access to your data. Creating a compute instance is a crucial step in Azure Machine Learning. CLI is useful for data scientists since it allows for the reuse of certain compute resources. This level of reusability makes for more efficient workflows. The steps involved in creating a compute target via CLI are to import the necessary libraries, initialize Azure ML Workspace, specify the VM size and parameters, use the configuration to create the instance, and finally, ensure successful creation has occurred. Use the configuration to create the instance and ensure successful creation. Remember that quotas for dedicated cores per region and VM family are shared with training compute clusters. Additionally, you can use the VS Code extension to create compute instances and clusters. When integrating with Git in Azure Machine Learning, make sure you know the following steps. To clone a Git repository into your workspace, create a compute instance, and open a terminal. After opening the terminal, you can access a full Git client and work with Git using the CLI experience. Know how to authenticate to a Git account with SSH. You can track code from Git repositories. You can submit a training job from the Python SDK or MLCLI, which are the necessary files that are uploaded to your workspace. Git repository information such as Azure ml.git.commit is stored and used for jobs with an estimator. And no Git related information is tracked if your training files are not in your Git repository or the Git command is unavailable. When creating data assets in Azure Machine Learning, there are several benefits you should be aware of. You can share and reuse the data by using data assets. Team members can easily access data without needing to remember file locations. You have seamless access. Data assets are readily accessible during model training, ensuring smooth workflows. Version tracking. You can keep track of all the versions of data, which is crucial for consistency and accuracy. To create a data asset, you need to specify a path parameter that points to its location. The types of data assets you should know are the URI folder data asset. This allows you to create a folder as an asset using Python code. It's ideal for organizing multiple files. You can also create URI file data asset. This lets you create a specific file as a data asset. You can also create a ML table data asset, which allows you to create a data asset in Azure Machine Learning using Python code suitable for structured data tables. Remember, these assets streamline data management, foster team collaboration, and maintain data integrity. Make sure you know the benefits and the creation process for each type to maximize your efficiency in Azure Machine Learning. Understand what an environment is. It is managed, reusable definition of the execution context. It contains the dependencies required for your scripts to run. Dependencies can include Python packages, Docker images. Make sure you know there are three main categories of environments: curated, user managed, and system managed. These three types will appear on the test. Curated environments are available in your workspace by default and are intended to be used as is. The main thing I want to call out here is that they help ensure faster deployment time. In user-managed environments, one thing you need to remember is that you must set up the environment yourself and install the packages required for your training script. Be aware of any dependencies needed for the model deployment. System-managed environments are managed by Conda, meaning Conda handles the Python environment for you. This can simplify the process significantly. Remember that environments are managed through your workspace, allowing you to register environments, get environments from your workspace to use for further training or deployment, create new instances of environments, and track changes as well. Understand why one would use registries. A registry can store and manage various artifacts related to your machine learning projects. Let's quickly recap the steps to share an existing data asset from a workspace to a registry. Step 1. In your Azure ML workspace, navigate to the data section, select the data asset you wish to share, click Register option to register this asset, then navigate to the registry and select Add Asset. Finally, you choose the data asset from your workspace that you registered. To recap, in this episode, we discussed how to design a machine learning solution, create and manage learning resources in an Azure machine learning workspace, create and manage assets in an Azure machine learning workspace. Remember, this group accounts for 20 to 25% of the exam, so keep that in mind when preparing for the exam. Thank you for watching episode 1 on designing and preparing a machine learning solution. Be sure to join us for episode 2, where we cover exploring data and running experiments.